Vector store architectures beyond just a vector DB. Vectors are only half the system. Metadata, filtering, scale, and ops decide which architecture actually works in production. 1. The 3 AWS native paths and why they exist. You'll see these 3 over and over in exam questions. Managed Knowledge Base, KB. 2. OpenSearch, Vector plus Neural Plugin. 3. Amazon Aurora with pgvector, plus Amazon DynamoDB for metadata. Each exists because one size does not fit all. 2. Managed Knowledge Base, the easy button. What it is: a fully managed RAG setup, ingestion, chunking, embeddings, storage, retrieval, minimal configuration, minimal control. When AWS wants you to choose it, fastest time to value, simple documents, no custom ranking logic, low ops burden. When not to use it, exam trap, you need custom metadata filters. You need hybrid search tuning. You need audit debug visibility. You need custom chunking or re-ranking. Memory hook. Knowledge base equals automatic gearbox. You don't tune it, you just drive. How to 3? OpenSearch Vector plus Neural Plugin, Enterprise Search Engine. What it gives you: vector search and keyword search, hybrid search, BM25 plus vector, metadata filtering at scale, re-ranking, fine-grained tuning. This is the most exam-heavy option. Typical architecture: embeddings stored as vectors, text fields indexed traditionally, filters on metadata, date, role, tenant, region. Why AWS loves it: scales well, handles complex queries, designed for search workloads. Memory hook. OpenSearch equals search brain, vectors plus keywords, filters, tuning. The 4, Aurora pgvector, relational first thinking. What it is: a relational database with vector support. Vectors are just another column. When it shines, you already use Aurora. Strong relational constraints, transactions matter, moderate data size. When it struggles, very large vector sets, heavy similarity search traffic, advanced search features. Memory hook. Aurora pgvector first, vector second. 5. DynamoDB, not a vector DB, but crucial. DynamoDB is not used for similarity search. It is used for metadata, access control, tenant isolation, fast key value lookups. Common pattern: vectors, OpenSearch or Aurora, metadata, DynamoDB, join at query time. Memory hook. DynamoDB equals identity and control plane. 6, AWS Static+1, Vector Architecture Edition. Static, vector store choice, index schema, metadata model, search strategy, vector hybrid SQL. +1, incoming query, user question. The architecture stays fixed. Queries vary. That's Static +1. 7, how AWS expects you to choose exam decision table. Choose Manage KB when simplicity, control, low ops, default RAG is enough. Choose OpenSearch when hybrid search needed, complex filtering, re-ranking, large scale, multi-tenant systems. Choose Aurora pgvector when strong relational needs, moderate scale, SQL joins matter, existing Aurora footprint. Use DynamoDB when metadata lookup, permissions, fast key-based access. 8, classic exam traps. Watch for these. Use DynamoDB for vector similarity, knowledge base for complex filtering, Aurora pgvector for massive search workloads. One vector store solves everything. AWS wants intentional trade-offs, not blanket answers. One memory story, don't forget this. The library system. Knowledge base equals self-checkout kiosk. Fast, simple, limited options. OpenSearch, professional librarian, knows keywords, topics, cross-references. Aurora pgvector, filing cabinet with SQL labels, structured, orderly, not built for crowds. DynamoDB, ID card system, who can access what? No single tool runs the whole library. Exam compression rules memorize. Simple RAG, managed KB, search plus scale filters, OpenSearch, SQL's relations, Aurora pgvector, metadata and access, DynamoDB. If an answer ignores metadata or filtering, it's incomplete. What AWS is really testing, they are asking, open quote, do you understand that retrieval is a system, not a database? Close quote. If your answer shows separation of concerns, scalability thinking, metadata awareness, you're choosing like AWS expects. Below are 3 concrete production-style examples showing when and why you'd pick Managed KB, OpenSearch, or Aurora pgvector plus DynamoDB. This is exactly how AWS expects you to reason in the exam. Real example 1, fast RAG for internal documents, managed knowledge base. Scenario: a company wants an internal chatbot over PDFs, policies, HR docs, Word files, procedures. Requirements: working in days, Not weeks, no custom ranking, no complex filters, low ops, architecture, upload docs to S3, use Bedrock knowledge base, ask questions, get grounded answers. Why this is correct: KB handles chunking, embedding, storage, retrieval, minimal configuration, no infrastructure. Why not OpenSearch here? Overkill, more ops, no extra benefit. Exam takeaway: simple RAG, low control needs, managed knowledge base. Memory hook: KB equals plug and play. Real example 2. Large enterprise search with filters, OpenSearch. Scenario: a legal research platform with millions of documents. Queries like open quote, find cases about construction defects from NSADO at 2018 for tenant X, close quote. Needs: semantic similarity, keyword matching, metadata filters, date, jurisdiction, tenant. Re-ranking architecture: documents, embeddings, store vectors, text in OpenSearch, use vector search, BM25 keyword search, metadata filters, optional re-ranker, access control via tenant metadata. Why this is correct: OpenSearch supports hybrid search, filters run at scale, designed for search workloads. Why not manage KB? Limited tuning, limited debugging, poor fit for complex filters. Exam takeaway: scales hybrid search filters, OpenSearch. Memory hook: OpenSearch equals enterprise search brain. Real example 3. Transactional app with embeddings, Aurora pgvector, DynamoDB. Scenario: a SaaS app where each user has notes and comments. Notes need similarity search, find related notes, strong consistency, SQL joins with users, projects, permissions. Data volume is moderate, not millions of vectors. Architecture: notes table in Amazon Aurora, content, embedding vector, project ID, use pgvector for similarity search. Store permissions and fast lookups in Amazon DynamoDB. User allowed project IDs. Query flow: 1. User query, embedding. 2. SQL query, vector similarity, where project ID in. 3. DynamoDB checks access. Why this is correct: SQL first design, transactions matter, moderate scale, existing Aurora footprint. Why not OpenSearch? Heavier ops, less natural for transactional joins. Exam takeaway: relational data plus vectors, Aurora pgvector plus DynamoDB for metadata. Memory hook: Aurora pgvector equals SQL app with vector spice. How AWS expects you to choose: real decision logic, requirement, correct choice, fastest RAG, low ops, manage KB, hybrid search filter scale, OpenSearch, SQL joins transactions, Aurora pgvector, metadata permissions, DynamoDB. Static+1 real-world framing, static vector store choice, index schema, metadata model, user query. The system is fixed, queries vary. That's static-1 in retrieval architecture. One final memory story, lock it in. The company library, knowledge base, self-checkout kiosk, fast, simple, no customization, OpenSearch expert librarian, knows keywords, topics, filters. Aurora pgvector equals filing cabinet with SQL labels, structured transactional, DynamoDB ID badge system. Who can see what AWS wants you to pick the right librarian, not bring a bulldozer?